I'm more focused on developing autonomous vehicles to handle jobs in areas where you don't want to put people, and to make it easier and safer for agriculture and stuff. I guess an ecosystem of autonomous vehicles, technology for the betterment of New Zealand.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.
Greetings and welcome along to the New Zealand Tech Podcast. I'm your host, Paul Spain, and recently, while attending the New Zealand Aerospace Summit in Christchurch, I had the privilege to sit down with Scott Spooner, founder of SPS Automation. In this episode, we're going to delve into the world of bespoke robotics and drone technologies. Absolutely fascinating discussion about this Christchurch-based company that's been working in everything from agricultural drones and robotics to drones that work together to produce light shows. The New Zealand Tech Podcast is proudly brought to you in conjunction with our show partners, which includes 1NZ, Spark, 2 Degrees, Workday, HP, and Gorilla Technology. So let's jump in. Okay, we're here at the New Zealand Aerospace Summit with Scott Spooner from SPS Automation. How are you, Scott?
Good. It's been a great first day at the summit. Some great technology and great talks today, and another exciting day tomorrow.
Yeah, looking forward to it. Now, most of our listeners probably don't know what SPS does, so maybe you can give us a sort of high-level overview.
A bit of a rundown, yeah. So SPS is a bespoke robotics company specialising in the development of novel aviation products, drones, big drones, small drones, and all the kind of smarts around how they operate, whether that be in swarm or beyond visual line of sight, or development of agricultural or drone light show systems.
There's a fair bit of variety in there.
I mean, the size of the aircraft changes, but a lot of the smarts, is across the different platforms. It's quite funny, actually. Some of the smaller drones that we've produced have such advanced avionics in them now, and like things like dissimilar redundancy across primary flight sensors. We're actually rolling that up to our larger drones, so it's pretty interesting.
And how long have you been operating?
So SPS Automation has been around for about 6 years. We started in my garage, just me, building drones and developing. We started with an aircraft that I built called Big Yellow, and we sort of have a bit of a passion around controlling some of the invasive plants in New Zealand, especially wilding pines. For those who don't know, wilding pines are rampant pine trees that grow all over the countryside. They suck up all the water out of the soil. They basically kill off all of our native plants and kill the land, really. So we wanted to come up with an idea of how to solve this problem with wilding pines, but we already spend a lot, the government spends a lot on helicopter broadcast spraying and ground crews coming in and chopping them down, but there's a real shortfall where you can't really access, by foot, but it might not be financially viable from a helicopter. So getting in there, we thought drone technology would be the way, and we started with that, and then we've been building machines for that for some time. We've branched out into larger spray machines for broadacre release spraying, developed AI systems for recognition of different plant species, calculating the size of different plants so that we can apply targeted chemical doses. But from that, we sort of grew and developed a whole variety of different types of aircraft system and do a lot of contract R&D for the greater aerospace community.
Right. And how big's your team now, Scott?
We have about 17 specialist engineers. We're based in central Christchurch, and we also have a production facility in Timaru. So we sort of dream up the craziness here, and then we send the designs and the build manuals down to Timaru to be produced in a very controlled environment.
Now, there's been, companies sort of building and developing drones in New Zealand over, quite a period. I remember Aeronavix doing, crowdfunding campaign. Maybe that was, a decade ago. How has this sort of space changed and evolved from the time you started to now? How much has the technology and the ability to kind of, I guess, leverage off the shelf sort of pieces that, mean you're not having to build everything from scratch, whether that's hardware or software and so on?
I mean, that's interesting that you mentioned aeronavics. So prior to SPS Automation, I was actually the chief engineer for aeronavics for 5 years.
Oh, okay.
And then when I left, we started SPS Automation. And since then, aeronavics has actually come together with SPS Automation, and we are just one company. So aeronavics is the production facility that I was talking about in Timaru, whereas SPS Automation is R&D. So moving on to your sort of next point around having to design everything ourselves versus being able to use off-the-shelf stuff, I still have a preference for designing everything myself, and it sort of is represented in our aircraft that we develop. Like, it was difficult in the early days where we had to design a lot of different systems for our aircraft, but the methodology we use around our sort of design aspect and engineering design is to make everything modular. So we design something for one aircraft, we roll that technology into the next aircraft, and we're sort of at a stage now where we can look at everything we manufacture and pull all the different modules that we've already designed and just left with a small part that we have to do. So it was difficult in the start, but having control over how everything works, especially from a quality point of view, is really important.
Yeah, okay. And what are the bits and pieces, what are the bits and pieces of the business that sort of really stand out commercially in terms of that have been working well for you? Is the Wilding Pines sort of part, is that quite a key part, or is that still a journey to make that work commercially?
I mean, it's been a balance between our contract R&D work and acting as a R&D enabler for other technology developers, for the universities, for, they kind of struggle in some areas where they need something really specific made, and we can help with that. And we sort of feed that back into our R&D projects. The Wilding Pines, we've had a great success with some of the trials that we've done. So we recently did a trial down in central Otago. It was about 500 hectares with a sparsity of trees of about 1 per hectare. So really spread out. It's not really suitable for ground crews there's a lot of walking involved in that.
Yeah, for sure.
But really not really great for helicopters either, because there's a lot of mucking around involved. So normally it would take several weeks for a ground crew to clear that area. We came in, spent 2.5 days flying our smaller drone, the AC-16, applying chemical in quite strong winds as well, dealing with that displacement of the chemical. But we were able to get through, 2.5 days, we were able to smash that job out. We sprayed every tree that they had.
What sort of number of trees are we talking?
Between sort of 350, 450-ish.
Yeah, okay.
In some really complex locations, overhanging cliff faces where you'd never get a helicopter or an abseiler in anyway. But we sent the drone in and did the spraying. And I mean, there's one side to put the spray onto, or the chemical onto a plant, but we actually went back 2 months later to verify our spray systems and verify that we actually got what we wanted, because it was pretty windy, and we got 100% kill rate across every single plant we sprayed, which is really incredible and a great sort of result for drone technology. Working in wildings it's quite difficult with spray application or chemical application from drones, because different operators have different results, because they have different experience levels with how their systems work, and there's a lot of misinformation around whether drones actually do work for doing some of these spraying operations. So it was great to see that we could go in and get a perfect kill rate on these trees.
Well done. That's really cool. Now talk about the capabilities and the size and scale of the drones that you built.
So we've done small drones, so sub kilo or about 1 kilo. but with all the smarts and bells and whistles, to operate in swarms of up to 3,000 and in unison. But then BFD aircraft, or the BFD 70 aircraft, that's a 4.5 meter from tip to tip multi-rotor with a maximum takeoff weight of around 160 kilos, carries a 50 kilo payload, and that has a flight time of around 2 hours at fully loaded weight. If we reduce that payload, say down to 25 kilos, we get about 4 to 5 hours, and we can get right up to about 10 to 12 hours if we're just carrying sort of 5 to 10 kilos. So depending on what you want to do with these aircraft, you can sort of optimize their use case. So if you're spraying, you just want to pump heaps of chemical through, load it up, shorter flights, but you can still, 2 hours is still a long time to fly.
Yeah.
And
these, what are they powered by?
So all of our bigger aircraft hybrid, which means that they have an onboard internal combustion engine coupled to an alternator that generates electricity to power a traditional electric propulsion system. So just like your normal drones, but instead of having a battery, I've got a big generator on board. Put fuel in, as long as there's fuel in the aircraft, that machine's in the air and working.
Yeah, and do you have some sort of battery backup if
so we definitely have a battery backup. The aircraft usually gets around, depending on which model, between 5 to 10 minutes of backup time should there be an issue with the engine. If you're just, say, for example, running low on fuel, the aircraft knows everything about what's going on with itself. So it'll come back automatically if it's running on fuel or if it runs out of chemical. But in the event that there was some issue, it gets about 10 minutes, which is actually longer than most agricultural drones will fly anyway. So you can still transit pretty far. In the worst case scenario, the aircraft will actually look for a flat area itself and place itself down. So it's got a lot of AI on board, smarts, guidance systems that handle all the kind of difficult nuances of operating an aircraft.
Right. What sort of communications and tech is built in terms of what can happen on the drone versus are they communicating up to the cloud for certain things? How does that fit together?
So with the BFD 70, we wanted to design it around teleoperation, which means aircraft in the wilderness doing spray operations by itself, and instead of having a specialist pilot on site for one per aircraft, having a centre where expert pilots can operate multiple drones simultaneously anywhere in the country. That posed some technological challenges for us, but because most drones is, you've got a controller and the drone's over there somewhere and you're dealing with flying it manually or watching it manually. So we still have that sort of controller point-to-point link, but we also included a 4G, 5G cellular modem, so it can work on the cellular network as well as the sort of ISM band, which is your local link. But the big game changer for us is Starlink. We have a Starlink dish on board, which is able to beam all the data that aircraft is capturing directly out to anywhere in the country where you can actually operate these aircraft from. Live video feed. The machine has forward and downward facing stereoscopic machine vision cameras, so it can do some of the heavy lifting regarding, is there something in the way? Do I need to detect something? Am I recognizing a particular type of plant? So most of these systems are autonomous, but we do now have the ability to have somebody operating this aircraft that can make the correct decision when the system deviates from the predetermined flight plan, which is really what pilots do with drones these days. There's no Top Gun anymore, no stick, hold onto your gloves, this thing's going. It's all press the go button and watch to verify that nothing is deviated from what you're trying to do. And then in the event that something does go wrong, making the correct decision based on the ground and air risk of what you're doing.
Right. And I mean, how hard are the technical problems that you work to solve, right? Because I guess you're on a journey with these things, and ultimately we head towards a world where it's completely autonomous.
Hard? No. So I mean, we try to develop everything in in-house. We've been doing this a long time. From the early days working at Aeronavics, learning about avionics and flight systems and flight computers, through to developing our own code bases to manage some of the communications systems and the different, C2 links or radio networks that we use. I mean, the reality is that me personally, it's way too stressful for me, but I'm backed by an incredibly smart engineering team. We recruit a lot out of Canterbury and New Zealand engineers. They have a sort of nous around them where they can actually think logically and come up with some really great stuff. So it's made a lot easier being backed by great people who are also enthusiastic around the aerospace and what we're actually, and believe in what we're doing. So hard, but great.
Yeah. And how you funded, how you work on that sort of basis at this point?
So we have private shareholders that fund us. So they're based in Timaru. They provide us with a lot of opportunities to develop these systems. And we also offset our development costs of our internal aircraft by doing contract R&D work for external parties. So, a university or a private company will come to us and get us to develop something, and we use that to feed back into our systems as well.
Yep. Now, you mentioned the idea of sort of swarms. We've had a chat on a previous episode with Isaac from Drone Shows, and I think you're probably developing the technology for for them. So how's that journey going to be able to make all those sort of things work?
Yeah, it's going really well actually. I mean, I was sitting here today in the conference, and my team was out performing a drone show at our test site today. So developing swarm technology has been fun. Isaac's drone show system is cutting edge, and I mean, I get to say that because I know what's under the hood, having quite a heavy involvement in some of the technology that we put into it. It's an exciting sort of place to be. You start working with 1 or 2 or 3, 4 drones, but when you've got 50 and you're trying to manage a fleet, as they sort of go up in numbers, you actually have to rely a lot more on the technology to just manage everything and then make sort of larger global decisions of how to operate them.
Yep. And how does that work, from, say, a positioning perspective? Because you can't necessarily use GPSs if you've got a lot of drones flying kind of near to each other and so on, or
we definitely use GPS.
Okay, so it's all about GPS, because I remember, what was he mentioning?
Redundancy for GPS or local positioning system.
Yeah, probably something local, I think, previously.
The drone show system that we've been developing, I mean, this is not our technology. We're the R&D developer of the technology for drone shows. They use dual RTK GPS, so it runs 2 independent GPS systems, which are RTK to give us heading, and we also have an internal secondary localization system that allows for redundancy if GPS, say for example, all the satellites turn off. Who knows,
Yeah.
That kind of works in a reverse GPS way. So instead of the satellites putting out radio frequencies that the aircraft interprets to calculate its position, you place out ground radio beacons essentially, and the aircraft can triangulate themselves within the coverage area. So things like that, which is dissimilar redundancy across primary flight sensors. So locational information, GPS is one type of technology, and then it switches to the backup system, which works on an entirely different methodology. So if something affects the first, it's unlikely to affect the second.
Yeah, okay. Oh, that's pretty cool. What does the future look like for you if you were to look sort of 5 or 10 years out? Where are you thinking you'd like to be?
Delivering really great aircraft all over the world. We have a pretty solid roadmap for our internal development. We have our BFD70. We're starting to look at the BFD Pro, which is the next sort of variant of it, which is a bit bigger, the bigger payload. And then sort of down the line, incorporating a whole variety of, I guess, an ecosystem of autonomous vehicles technology for the betterment of New Zealand, right through to like herbicide alternative invasive plant control. So how can we not put any chemical into the environment? What about organic farms? Like, if we've got to do work near that, how do you control that? And then big aircraft. We've got some big stuff planned on the way. We were sort of looking at 250 kg plus payloads.
People?
No people. I mean, helicopters have been around for a long time, planes have been around for a long time, and there is a sort of space for personal air vehicles and air taxis and all of that kind of stuff. And as exciting as that is, I'm more focused on developing autonomous vehicles to handle jobs in areas where you don't want to put people, and to make it easier and safer for agriculture and stuff in New Zealand like that.
Yep. And can you speak to the regulatory environment? How's that been for you? And, what's the current sort of status there in terms of where you want to go?
So the 102 system, the Civil Aviation Rules Part 102 system, it's been hard, but really good. We wanted to do some crazy stuff. We went to the CA and said, look, I want to fly a 160 kilogram drone in swarms, beyond visual line of sight, teleoperated in the mountains, upside down, doing flips, flashing lights at night. Who knows? When we went to them and said all the sort of crazy stuff that we wanted to do, they were kind of like, ooh. But we sat down and worked out how to go through this. And, at the start, they didn't know. Like, we didn't have a written down, this is how to do it. But we worked with them and actually came up with a pathway that allowed us to get to where we need to go. Since we started that journey, we've worked out how to set up maintenance organizations and training around our aircraft. We've set up 2 experimental aircraft bubbles, or geographic locations, where we can perform complex operations with experimental aircraft in controlled environments. It has been approved by the CAA without sort of restriction, and that is really, really incredible. And there's not anywhere else in the world that I think that we would be so lucky to get away with what we're kind of doing here. And it's not even getting away, it's
because what you're doing is safe. It's just that they're flexible enough that you can...
the flexibility. In New Zealand, you say, I think it was in a presentation earlier today, I want to build a flying T-Rex with rockets and, that goes into space and changes color or something. And you can do that if you can prove the safety case.
Yeah.
The flexibility is very enabling in New Zealand. So it's a very, very powerful system, but there is some complexity in getting to that point. Because nothing is prescriptive, there's no written way. You want to do that? This is how you have to do it. You have to come up and tell them how you're going to do it. And quite often, I mean, even especially for us, like, I spent a huge amount of work learning about different sort of risk analysis systems, the SORA 2.5 system, which is specific operational risk assessment, going through that, trying to work out how to adapt that for a non-specific aircraft. And it's a challenge. I found it mediumly fun. Medium as in I actually got what I wanted at the end, but
yeah. Hard work to get
mentally tough.
Yeah. Overall, we're in a good state, but there's more work and more iteration to do.
I think we're in a great state. I think ultimately adding some standards around some of the things, like some of the training syllabuses around what constitutes it, training for a drone pilot. What standard do they actually need to have? What knowledge do they need to have? How do you get somebody to do maintenance on your aircraft? What standard do they have that that if you take your aircraft to that person to perform maintenance for you, that they're going to do a good job and your aircraft is going to be airworthy afterwards? I mean, this has been around in crewed aviation for years, but in the unmanned scene, just the way it is, it's all a bit grey. So bringing some standards in around training, I think, would be quite good, and airworthiness standards.
Yep. Oh, that's really interesting. Anything else you wanted to add, Scott?
We're in Christchurch, SPS Automation. If you've got a crazy idea, it doesn't matter whether it flies or rolls or dancers in the street, let us know and we'll see if we can help.
Fantastic. All right. Really appreciate your time, and all the best for the rest of the New Zealand Aerospace Summit.
Yeah, thank you very much.
All right. Cheers.
Cheers.
Well, thanks for joining us on this episode of the New Zealand Tech Podcast. A big thank you, of course, to our show partners, to 1NZ, Spark, 2 Degrees, Workday, HP, and Gorilla Technology. All right, I'll catch you on the next episode. This is Paul Spain signing out. Cheers.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.